Hello everyone, welcome back to our course in college algebra. In this video we are going to discuss the concept of the rate of change of a function. This is related to the previous video, the one where we talked about finding the slope of a line joining 2 points. Okay, now the concept of slope really only applies to a linear function. The idea of a rate of change can be applied to any function. Let's look at an example here. Let's try to find the rate of change in f of x equals x squared minus 3x plus 1 from x equals -2 to x equals 5. Okay, so this is my function. F of x equals x squared minus 3x plus 1. It is not a linear function because linear functions can't have a second degree term like this. Okay, so not a linear function. Okay. Here's how you do it. You're making this fraction here. You're going to look at the change in the outputs of the function and divide that by the change in the inputs of the function. Exact same idea we're doing here. I would also remind you that when we're talking about points on the graph of a function, those are input-output pairs. So the x-coordinates of points on the graph represent the input values, and the y-coordinates of points on the graph represent the output values. So when we say change in output over change in input, we really are talking about delta y over delta x. Okay? So in other words, here's what we're going to need to do. We're going to need to do f of 5 minus f of -2 over 5 minus -2. I'm going to do some scratch work right over here. I'm supposed to do f of 5 minus f of -2. Well, before I can do that, I need to figure out what f of 5 actually is. And I need to figure out what f of -2 actually is. Remember back in the video about function notation, I talked about replacing the x's with these blanks. Okay, so if I want to find f of 5, I put a 5 in the parentheses on the left-hand side, and I have to replace all the blanks on the right-hand side with 5s. 5 squared is 25, 3 times 5 is 15, 25 minus 15 is 10, f of 5 is 11. F of -2, I put a -2 over there, that means I have to replace all the blanks with -2's. -2 squared means -2 times itself. -2 times -2 is positive 4. Okay, that's a 4. -3 times -2 is positive 6. 4 plus 6 is 10. Plus the 1 is 11. So, what we've got here is a rate of change of 0 from x equals -2 to x equals 5. So, between those two x values, the rate of change is 0. Let me look at something a little bit different. I'm going to do this. Let's change the problem up a little bit. Let's look at the rate of change from x equals 4 to x equals 5. Well, I'm going to follow the same procedure, change in output over change in input. F of 5 minus f of 4 over 5 minus 4. We have to figure out what these two things are. Okay, now f of 5 is going to be 11 again. We computed that last time, right? 5 squared is 25, minus 15 is 10, plus 1 is 11. Okay, we already did that. We do need to do a little bit of work to figure this out. 4 squared is 16, 3 times 4 is 12. 16 minus 12 is 4, plus 1 is 5. Okay, so in the last example we looked at, we found out that the rate of change from x equals -2 to x equals 5 was 0. Here, if we look at the rate of change from x equals 4 to x equals 5, we see that the rate of change is 6. Okay, now, when we're dealing with non-linear functions like this, the rate of change will vary depending on where you're starting and where you're stopping. With linear functions, the rate of change is always the same, and the rate of change for a linear function is equal to the slope of the linear function. Nonlinear functions, it's a different ballgame. Okay, so from x equals 4 to x equals 5, this function has a rate of change of 6, telling us that for every 1 unit increase in output, for every 1 unit increase in input, the output is increasing by 6 units on this interval. If we look at a different interval, we may very well get a different rate of change. Okay, so this is the basic idea for rate of change. Change in output over change in input. Now, for those of you that go on to study calculus, this business of rate of change is very important. In fact, one of the big calculus operations, the derivative, differentiating a function, is basically trying to tell us how the function is changing. And it does that by looking at the rate of change. Okay, so these quotients, where you take change in output over change in input, become very important in calculus. And you should be pretty familiar with it because you're familiar with the slope of a linear function. And rate of change is the same basic idea, just applied to new classes of functions.